Hi, my name is Hubert Liang. I am a data engineering practice lead. Welcome to my course, Implementing Azure Stream Analytics Job, where I'll be walking through on streaming data with an emphasis in using Microsoft Azure Stream Analytics. My passions are in big data, and I hope you will find this course useful as a background to streaming data and the uses of Azure Stream Analytics. It is important to understand around streaming data, especially in the world where there is a glut of moving data, such as through IoT sensors, stock markets, river levels, and many more. Having a grasp of the fundamentals of streaming data is important as a data engineer or IoT developer. First, let us start with an overview of this course and what you will be learning. To start off, you'll be learning some of the key elements around what is streaming or hot data and its benefits. Then, we will be covering off what Azure Stream Analytics is and its major concepts, such as workflow, pipeline, and its query features, such as windowing functions and machine learning. Lastly, we would wrap up with the applicability of these topics in action, where I will be doing a live demonstration of creating an Azure Stream Analytics pipeline and tying this up with the major features we have covered off. Now, let's get started. What is live streaming data? In the world of big data, the acronym of the 3 V's are everywhere. The first is the speed at which the data is moving, say from point A to B. Imagine you want to be able to quickly track the number of vehicles passing through a toll booth. The speed at which this data is arriving and processed encapsulates this concept. In the world of cloud computing, the network transmission of these packets of data has enabled the evolution of streaming data. The second concept is the variety of the data. Streaming data is needed, albeit traveling at speed, and can come in different formats, such as structured or semi-structured. Imagine this can be the payload of the car booth data, which could be in JSON, CSV, or Avro. The data can originate from IoT, or Internet of Things, transactions, cloud applications, web interactions, or mobile devices, and many more. Sometimes there can be a blend of this data with static data, such as that of data in the database. The last V is volume, and this is pretty straightforward. This is the amount and the quantity of data that is captured and carried, and is usually measured in the scale of gigabytes. Having enough of the data, whether it be in any format, is important to enable insights and analytics. Now, let's just recap. Velocity, variety, and volume makes up big data. What are the benefits of streaming data? Business insights. This wouldn't come as a surprise. As business events and transactions are transpiring, this data will need to be captured. Some of the use cases for this can be in analyzing real-time telemetry streams from IoT devices, weblogs, geospatial analytics for fleet management, remote monitoring, and real-time analytics for point-of-sale data. Secondly, increased competitiveness. Businesses are always looking for ways to gain a competitive advantage, and using streaming data can allow you to discern trends and set benchmarks faster. Next, cutting preventable losses. With the help of streaming analytics, we can prevent or reduce the incidents such as security breaches, manufacturing issues, or customer churn. Lastly, analyzing routine business operations. Streaming analytics provides organization with an opportunity to ingest and obtain insights from real-time data. Next, we will be covering off what Azure Stream Analytics is, the fun part. What is Azure Stream Analytics? Well, it is a fully managed serverless offering in Azure. You don't have to provision any hardwares, manage any clusters, or update any operating systems. It is easy to use. Azure Stream Analytics manages your jobs, so you only focus on the business logic and not the infrastructure. Programmability. Azure Stream Analytics provides simple SQL-based query languages that can be augmented by powerful temporal constraint, which we will cover off a little bit later. Lastly, pay as you go. Stream Analytics can process millions of events every second with ultra-low latencies. The scaling up and out capability allows you to control the costs of the jobs that you create. Now let's focus on the Stream Analytics workflow. On the left, we start as the ingestion. Interpret this as a reservoir of source data. This can be through IoT devices, log files, customer data, weather data, business applications. This data can be stored in event hubs, Azure Storage Blob, or IoT Hub. Now the fun part, the analyze part. Azure Stream Analytics can act as the aqueduct and pulls the data from the reservoir. Now this can be transformed, or it can be married into some reference data that's in Azure SQL database or blob storage. You can always do Azure machine learning services on this to supplement the data. Now lastly, on the right you have the delivery of the data. Now this data can be pushed into a service bus, Power BI. Next, let us cover off some of the use cases of windowing functions using the car tool booth as an example. Hopping window. This gives an aggregation of the number of cars tooled over the past 10 seconds with 5-second hops. Session window. This provides an aggregation of the number of cars tooled within 5 minutes of each other. Sliding window. This provides an aggregation of the number of cars of all vehicle types that are tooled for more than 5 times in the past 10 minutes. Tumbling window. This provides an aggregation of the number of cars per time block for every 10 seconds. Snapshot window. This provides an aggregation of the number of cars tooled at a snapshot of time, say 10 AM. Streaming units. Streaming units are presented as the computing resource that are allocated to execute the Stream Analytics job. In other words, it is known as the engine or the compute of the job. Exact once delivery and processing. Exactly once processing. This guarantees that given a set of inputs, the system always returns the same results. For example, this is important for repeatability. Exactly once delivery. This guarantees all outputs from the event are delivered to the output exactly once. Having covered off the theoretical parts of Stream Analytics, let's cover off what the GUI looks like for Stream Analytics in the Azure portal. Now, you can see I've already provisioned the resources and the jobs for the Stream Analytics job. Here, this is the overview page. You will have the inputs. Here, I will have the event hubs, which is sourcing the car tool booth data, which is also referred to as the reservoir. We've got the query on the right. This is aggregating the number of events coming through according to the tool ID. And we're looking at a tumbling window of 3 minutes, which we've also covered off. Then, where is this data being pushed? You can see the outputs, Cosmos DB. Cosmos DB is a globally distributed database for Azure. It is highly scalable and highly available. Going down, we've also covered off streaming units. Resource allocation. Now, streaming units can be scaled up or down. Here, you can see the utilization is at 19%. Let's have a quick wrap up of what we learned in the session. First, we covered off what live streaming data is. Remember the 3 V's? Variety, velocity, and volume. Next, we covered off Azure Stream Analytics, some of the fundamental stuff, the workflow, the pipeline, and the functions. Lastly, we went through a use case of car tool booth and how to set up the Stream Analytics job in the Azure portal. I hope that you've enjoyed this course and found this useful. If you have any questions, please refer to the LinkedIn at my start of the slide. For further resources on how to set up the resources for the car tool booth, here are the resources. Thank you.